Welcome back to the deep dive. So for years, if you wanted really smart AI features on your phone or laptop, complex summaries, generating images,
Uh-huh.
you basically had to beam your data out across the internet
Hmm.
to some giant server farm somewhere.
Right, the classic smart library model. Hugely powerful, sure, but often laggy. You'd hit send and wait.
And that network delay can be frustrating. Plus, the privacy side of things.
Right.
All your personal info just heading off into the cloud.
Exactly. Well, that whole picture is changing, like, incredibly fast. Today, we're diving into this massive shift towards on-device AI
hmm
and what's really become the new standard, the hybrid model. So our mission today is to unpack what's actually running locally on your device right now.
Yeah, why does some stuff feel instant now?
And what are the different takes on privacy?
Yeah.
Because Apple, Google, Microsoft, they're not all doing it the same way.
Okay, let's maybe just set the scene quickly. So cloud AI,
Okay.
that's the traditional big brain in the sky, right?
Yep.
Massive models. Great for really heavy-duty tasks, complex reasoning.
Mhm.
But yeah, slower, needs that internet connection, and privacy is, well, it's a factor.
Because the data has to travel. But now we've got this on-device AI, the pocket expert, you called it.
That's a good way to think about it. Smaller, specialized models running directly on your phone or laptop silicon.
So it's super fast.
Instantaneous, often.
Yeah.
Works offline too, which is huge. And the key thing, your data stays put. It doesn't leave your device for these local tasks.
Okay, and then the hybrid model bridges these two.
Precisely. It's pretty much the default now. Your operating system, it acts like a smart traffic cop.
Okay.
It uses that local pocket expert for quick things dictation, maybe a quick photo touch-up. But if you ask for something really big, like summarizing a 50-page report with charts,
Then it needs more horsepower.
exactly. It securely hands off that task, often anonymized, to the cloud when necessary.
And the fascinating part is you're using this constantly without even thinking about it.
Yeah.
That instant voice typing. That's it. It really feels like magic sometimes. But the big question is, why now? Why did this suddenly become possible in, say, the last couple of years? Running these models locally seemed like science fiction not long ago.
Right. What changed?
Well, it boils down to solving three main problems: speed or latency, really privacy, and efficiency, like battery life and cost.
Okay, so let's tackle the hardware first. I keep hearing about specialized chips, not just faster general processors. Is that the key?
Absolutely crucial. We need to talk about the NPU, the neural processing unit.
NPU, got it.
So historically, we had CPUs for general tasks, GPUs for graphics, but AI math is, well, it's very specific, lots of repetitive calculations.
Okay.
The NPU is a dedicated piece of silicon designed just for that kind of math.
So it's like having a specialized tool instead of a Swiss Army knife.
Perfect analogy. Because it's specialized, it does those AI calculations using way less power and generating much less heat than a CPU or GPU trying to do the same job.
Ah, okay.
Mhm.
So without that, your phone would, overheat? Or the battery would just drain instantly?
Pretty much. Trying to run constant AI features on general hardware wasn't sustainable. The NPU makes it practical.
And it seems like everyone's on board with this. Apple's M-series chips, Google's Tensor, the Snapdragon chips in high-end Android phones, they all have NPUs now.
They do. It's become table stakes. And Microsoft actually put a number on it. They defined a Copilot PC as needing an NPU with at least 40 TOPS.
QoPS.
Trillions of operations per second. It's a measure of that AI processing power. So 40 TOPS is basically the minimum entry fee now for the full suite of modern on-device AI features on Windows.
Wow. Okay, so if your machine doesn't hit that, you're kind of stuck in the previous generation.
In terms of these new local AI capabilities, yeah.
That really highlights how important the hardware has become. Okay, so that's the engine sorted. We have the specialized NPU. But how did they actually fit those massive AI models, those brains,
Yeah.
onto a device with limited memory? Did they just make them dumber?
Not exactly dumber, no. They made them smaller using some really clever software tricks. Optimization is key here. Two main techniques really stand out.
Okay.
First one is quantization. Think of it like compressing a really big, high-quality photo into a smaller JPEG file.
Okay, I get that analogy. You lose a tiny bit of detail maybe, but the file size shrinks dramatically.
Exactly. With quantization, you reduce the precision of the numbers used inside the AI model, maybe going from, say, 32-bit numbers down to 8-bit integers.
Wait, reducing precision, doesn't that make the AI less accurate? Less smart?
You lose a little bit of theoretical accuracy, yes. But for many common tasks, like understanding your voice or doing a quick translation, the difference is negligible to the user. And the payoff is huge. The model becomes much smaller and runs way faster on that NPU.
Okay, so quantization shrinks the model file size. What's the other big software trick?
That's distillation. This is more like, well, training an apprentice. You take a huge, powerful teacher model, one that runs in the cloud, and you use it to train a much smaller student model.
So the little model learns from the big one.
Exactly. It learns to mimic the behavior and knowledge of the teacher, but in a much more compact form. Google's Gemini Nano, for example, is a result of this. It's distilled down to run efficiently right on Android devices for those instant lightweight tasks.
Right, I see. So you combine the efficient NPU hardware with these cleverly shrunk models through quantization and distillation, and suddenly local AI becomes practical.
Add in the user demand for speed and privacy, and boom! That's the perfect storm that led to this shift around 2023, 2024.
Okay, so we know what can run locally and why. Let's talk about the how. How does the system decide when to run locally versus going to the cloud, that hybrid model logic?
Right. So the operating system has this layer, often called an AI runtime. Think of Android's AI core, or the whole Apple Intelligence System stack. This runtime is the decision maker.
It's the traffic cop again.
Yep. It looks the task you're asking for and figures out the best route.
But isn't that decision process itself kind of complex? Checking the task, checking connectivity. Doesn't that add its own delay? Why not just default to the cloud if it's tricky?
Because even a complex local decision is usually way faster than the inherent latency of sending data out to the cloud and waiting for it to come back. That round trip is the real speed bump.
Ah, okay. So the runtime quickly checks a few things. Like what?
First, task size or complexity.
Hmm.
Is it a simple request, like suggesting a quick reply to a text that's almost certainly local?
Versus, say, analyze these 3 huge PDF attachments and give me a summary.
Exactly. That sounds like a job for the cloud's bigger brain. Second, it checks connectivity. Simple enough, if you're offline, it has to use the local model or tell you it can't do it.
Makes sense. What else?
There's also a notion of confidence. Sometimes the local model might handle a task, but it's not entirely sure it got the answer right. Maybe the voice command was muffled or the translation is ambiguous.
So it might double check.
It might escalate that query to the cloud, perhaps in the background, to get a potentially better or more nuanced answer, or just to validate its own result.
Okay, this gives us a clearer picture. The local model is like a sprinter. Super fast, totally private, great for short, defined tasks. Voice typing, quick photo edits, live translation right there on the spot.
Perfect. And the cloud model is the marathoner. It can handle almost anything. Huge context windows, best for really complex analysis, deep research, or creative open-ended stuff like writing a long essay.
And the hybrid system is the bridge, the relay team, managing that handoff smoothly.
Exactly. It handles the stuff in between. Maybe you ask it to summarize a long email thread. It might process the text locally first, figure out the key entities without sending your emails anywhere.
But then realize the actual summarization needs more power.
Right. So it might send an anonymized request about the content to the cloud for the heavy lifting, then integrate the result. You, the user, hopefully never even noticed that baton pass happen.
Okay, this is super helpful. Let's now apply this framework to the big platforms, because you said they're taking different approaches, right?
Yeah, it's fascinating. Same tech, building blocks, but different philosophies, especially around privacy.
Let's start with Apple Intelligence. Their approach seems very deliberate.
Very much so. Their mantra is local first, almost aggressively so. Things like the new writing tools rewriting, summarizing within apps, or the smarter Siri that can understand context from your mail or messages.
That all runs on the device.
Primarily, yes. And the crucial point is how Siri accesses that data. It looks at your mail or messages locally to understand your requests, like pull up the photos from Sarah's party without sending the content of your messages or your photos off the device.
That's a big privacy claim. But what happens when a task is too big for the local NPU?
Then it escalates, but not just to any generic cloud. It goes to what Apple calls private cloud compute, or PCC.
And that's different how?
Well, Apple says it runs only on servers using their own Apple Silicon chips. The data sent is cryptographically secured, it's not stored, it's used only for that specific computation, and then it's gone. Ephemeral. And the real kicker for their privacy argument. They claim the software running on these PCC servers will be publicly logged so independent security experts can inspect it to verify those privacy promises.
Quite a statement. Building trust through transparency. But there's a catch, isn't there? Device compatibility.
Huge catch. Because it relies so heavily on that specific NPU power and memory architecture found in their latest chips, Apple Intelligence is limited to the very newest iPhones, like the 15 Pro and newer and Macs or iPads with M-series chips.
So if you have a slightly older device, even a fairly recent one, you're basically left out of this whole new AI ecosystem for now.
That seems to be the case, yeah. It's a hard requirement.
Okay, let's shift gears to Android and Samsung. What's their approach? The foundation seems to be Google's own setup.
Right, the core is AI Core, which is Android's runtime, managing Google's small on-device model called Gemini Nano.
Gemini Nano. Okay, and what does Nano handle locally?
It's the engine for a lot of those instant features. On Google's Pixel phones, it famously powers the Recorder app's summaries. You can record in a meeting and get a summary even if you're completely offline.
I've seen that. It's pretty cool.
Yeah. Also, things like smart replies and messaging apps. Samsung builds on this with their Galaxy AI features, their live translate during calls, or the interpreter mode for face-to-face conversations.
Those work offline too.
Many of them do, yes. Even in airplane mode, which really demonstrates that on-device power. However, some features definitely lean on the cloud.
Like what?
Samsung's generative edit in the photo gallery, where you circle something, move it, and it fills in the background, that kind of complex creative image manipulation usually needs the power of a larger cloud model to generate realistic fill-ins.
So their approach feels more blended by default.
I'd say it defaults to hybrid, yes, but a key part of their philosophy seems to be user choice. You'll often find settings or toggles that let you disable cloud processing for certain features if you'd rather stick strictly to local-only operation, perhaps for privacy reasons, or if you have limited data.
Right, giving the user control over that trade-off.
Yeah.
Okay, finally, Windows. They made a big splash with the Copilot PC branding and that 40 TOPS requirement. What runs locally there?
A lot of the focus for local processing on Copilot PCs is on enhancing the immediate user experience, especially around communication.
Like video calls.
Exactly. Windows Studio effects are prime examples. Things like automatic background blur, correcting your eye contact so you always look like you're looking at the camera, or advanced noise suppression to filter out background sounds.
And those run instantly on the NPU.
Instantly. Zero lag because it's all happening right there on your machine. No sending video streams to the cloud for processing.
Okay, and then there's the big one, Recall. That stirred up some discussion. How does that fit into their local-first strategy?
Recall is maybe the clearest example of Microsoft drawing a line in the sand for privacy with on-device processing, despite the initial confusion or controversy.
Yeah, people were worried about screenshots being stored.
Right. But Microsoft has been very clear. Recall works by taking encrypted snapshots of your screen activity locally. This data is stored 100% on your device. It's encrypted by device encryption and requires you to authenticate to access it, and it is never sent to Microsoft or used to train their AI models.
So the whole point is local semantic search, finding something you saw on your screen days ago.
Exactly. You can search for concepts like, find that recipe with saffron I looked at last week, and it searches across your local snapshot timeline. It's designed as a purely local, user-controlled memory aid.
So Microsoft's approach is a clear split. Keep the really sensitive personal timeline data, Recall, and real-time effects, studio effects, strictly local and encrypted.
While the broader Copilot Assistant features, the chat interface, complex reasoning, generating long documents, that stuff generally leverages Microsoft's powerful cloud AI models.
Interesting. Okay, so if we boil this down, we're seeing 3 different privacy philosophies emerge.
Seems that way. Apple is going for privacy by architecture. They're building this specific, auditable, private cloud compute system as a secure extension of the device.
Then Android, with Google and Samsung, offers privacy by choice. They provide the hybrid capabilities, but often give you toggles to control the cloud connection.
And Windows, with Copilot PCs, is emphasizing privacy by split design, a hard line. Sensitive stuff like Recall stays local and encrypted, while other AI tasks go to the cloud.
And look, you don't just have to take their word for it. If you want to actually feel this on-device processing.
Try the airplane mode test.
Exactly. Put your phone in airplane mode.
Yeah.
Then try dictating a message, or maybe using a feature like Samsung's Live Translate if you have it, if it works instantly offline.
That's the NPU and the local model doing their thing. That's your pocket expert at work.
And those real-time, low-latency tasks are really where local AI shines brightest right now, aren't they?
Definitely. Instant voice typing that keeps up with you, those offline summaries like on the Pixel Recorder, the immediate video call enhancements in Windows Studio effects, real-time translation. These are the things that just feel fundamentally better because they're running locally.
So, wrapping up, This hybrid model really does seem to offer the best of both worlds, doesn't it?
Yeah.
You get the speed, the privacy, the offline capability of local AI for everyday stuff.
And you still have access to the immense power of cloud AI for the really big, complex jobs, all managed pretty seamlessly by the OS in the background.
You don't have to constantly decide local or cloud
Yeah.
for every little task.
Which leads us to a final thought to chew on. These new hardware requirements, the powerful NPU, often more RAM, they signal that the physical device itself is becoming critically important again.
More so than just being a thin client connecting to the cloud.
Absolutely. And here's the interesting part. Those small on-device models, like Gemini Nano, they're constantly being updated in the background, refined through more distillation, getting better over time, almost like app updates.
So the Pocket Expert you bought 6 months ago is actually smarter today.
Potentially, yes. Which means investing in hardware with a capable NPU isn't just about current features, it's about future-proofing. It's central to accessing ongoing improvements and maintaining device longevity in this rapidly evolving AI landscape. Your phone's brain keeps learning locally.